Welcome back. ProGeologist here with GeoEarth Solutions. Last time we took a look at defining spatial questions and the importance of spatial thinking. This time we're going to take it a step further and we're actually going to define what a GIS is. Now, it's kind of twofold, and we'll get into that. When we take a look at what's going on within the realm of GIS, we have to realize that geographic information systems is one thing and geographic information science is another. We'll differentiate between these two as we dive into this. So keeping in mind that a GIS, from the standpoint of the systems, we're looking at computer-based hardware and or software that combine into a system. This system, if you will, that can be used to creatively locate reference data. It can also spatially reference data. A GIS as a system, it stores and organizes locationally referenced data. And so those data that you've referenced, that allows a database to be created, a component, if you will, that is key in spatial analysis. We can also perform such spatial analyses within a GIS as a system. We can create visualizations, and usually what happens is those visualizations come out in map form. That's not always the case, though. This could include tables, it could include graphs, and especially in the last couple of years, even dashboards to help run real-life analytics. So when we look at this image here on the right, we begin to realize that we can take layers, much like we've talked about in the last episode, and we can see that we have street data, and we can combine that with building data. Combine that with things like tree coverage or vegetation data, and before you know it, you have an integrated system, there's that key word there, that helps us define geographic information systems, or GIS. Now, when we continue to look at this, what we have to realize, as mentioned before, is GIS as a system is actually very different from geographic information science. Now, different in the extent that these two are used almost synonymously throughout the industry, but they're really different because you're combining things like GIScience, that is geographic information science, that's what we're talking about here, right? Generally with things like earth science and even computer science. So CS plays a huge role in this. Geographic information science, or GIS from that standpoint, is really the theory behind how to solve spatial problems. How do you analyze and pull out the spatial component to meet a challenging question and solve a challenge that society faces? Okay, and we do that usually by implementing GIsystems or GIS from that standpoint. GIScience, if you will, is the study design of the data and the methodologies that go into that system. So from the previous slide, if you think about how did we get the vegetation data, that may have been a remote sensing exercise. Such exercises fall into the realm of geographic information science, or again, GIScience. At the same time, you may use computational techniques and data structures. You may be using machine learning, or ML, and artificial intelligence systems to help you remote sense or identify pixels or identify certain aspects within a data set. All that being pulled from the GI system and integrated through GIScience to be put back into storage within the system. So the general use and representation of such analyses and even ethics of georeference data ties into GIScience. So there's where we break down the idea of geographic information science as a GIS and geographic information systems as a GIS. Not confusing at all, right? Really good Venn diagram, if you will, is here on the right. We look at GIScience, we look at earth sciences such as geology. As I've mentioned, I'm a geologist by training, and so I really am intrigued by concepts, the physical phenomena that exist in earth sciences. You've also got computer sciences, and we can see there's overlap, GIS development, and in this case, both in the system and even in the science, a little heavier on the system from the computer science standpoint. We've got numerical coding. So you could look at coding systems or languages like R or Python, and then you also look at the back end, right? How do you integrate a spatial concept into something that is a physical earth phenomena? Well, CS, computer science, can help us do that, but we need both the sound understanding of GIScience and the understanding of the earth sciences to, no pun intended, lay our foundation, put our bedrock into play before CS can come in and really help us make an assessment of what's going on and execute. And of course, we've got GIS use that spans multi-facets. It's not just earth sciences, but we could see how the earth sciences would immediately benefit from the use of GIScience or GIS in general. So there we have it from that standpoint. We can also turn around and we begin to look at what a GIS really is from the standpoint of, again, science in the system. What we begin to realize is that a GIS is a combination of things. It's a very broad, generalized topic. It's the science of gathering, storing, and processing, and even delivering spatially related data. It's tools and techniques such as land surveying, remote sensing, cartography, geoscience, GPS, photogrammetry, and more. It goes beyond our world, really. There's a lot of GIScience and GIS being implemented with all the exploration that's going on Mars right now via NASA, JPL, and many other agencies. But GIS from that standpoint, we can take it a little bit further. Bring it back home if you want to, actually, in the sense of taking it further back to home. The social structures that enable and act these sciences and these tools. So how does redlining within a county or within a state attribute to some of the negativity that may occur? Or how does positive science, environmental science, proliferate through the system? All that can be tied into a GIS. And finally, the most important thing that we have to think about when it comes to GIS, both as a system and as a science, are the people enacting it all. We're operating as scientists. And so our biggest challenge is going to be eliminating biases. And many will say there's no way to eliminate biases. There's a whole other lecture that we can have on this. I agree. Looking at the earth sciences that are very closely tied in with my career and also tied in with my academic training, I try my best to eliminate the biases that will be present. It's part of my job. So the people enacting it and enacting all of this as a system and as a science are very key. Now, there's a book out there that many folks who are starting in a GIS class may actually have read or may have sitting on their shelf, or they may be purchasing for the next semester. But Paul Wallstad, he pushed out a book and published what is called GIS Fundamentals, a first text on geographic information systems. Okay, the 6th edition is currently out there. Don't know if the 7th edition is on the horizon or not. But within that, Paul states something to the effect of a GIS is a tool or a computer-based system to aid in the collection, maintenance, storage, analysis, output, and distribution of spatial data and information, close quote. Now, if GIS isn't tied to the people enacting it all, I don't know what a GIS is then. And so we have to think about that. How are we as GIS professionals, earth scientists, computer science professionals, how are we collecting, maintaining, storing, analyzing, outputting, distributing, and essentially interpreting spatial data and information? So it's a lot to consider, a lot to digest. But there we have it. That is a GIS in a nutshell. Hope you'll tune in next time for our next little bit as we dive into some great examples of GIS programs and initiatives.